So how do we pick a random sample, assign treatments in a randomized experiment, and model random phenomenon through technology or a random digit table? First off, let's review a couple of definitions. Random sampling involves using a chance process to determine whether members of a population are included in the sample. And in the case of an experiment, a random assignment refers to the fact that experimental units are assigned to treatments using a chance process. There are a couple of different ways of picking random samples or assigning treatments in randomized experiments. Two examples are using technology such as a calculator or computer, or using a random digit table. Let's go through these methods. For choosing a simple random sample with a calculator, the first step is to label each individual in the population with a distinct numerical label from 1 to n. The second step is to use a random number generator to obtain n different integers from 1 to n, with small n being the sample size that you want. Now let's try this out with the TI-84. Let's say that we have a population of 100 and we want to randomly sample data from 5 of these individuals. What we want to do on the calculator is click on Math, scroll over to Probabilities, and at number 5 you should see Random Integer. And here a nice little window should pop up with the giving you the option to paste in a lower bound and an upper bound. Since we have a population size of 100 and want to sample from 5 of these individuals, we enter those values and we make click paste. And click enter again, and we should receive 5 different integers from 1 to 100. For choosing a simple random sample with a random digits table, the first step is to give each member of the population a numerical label with the same number of digits. So that means that if the population size has 2 digits, you would want to label all members with 2 digits by numbering numbers 1 through 9 with numbers with the leading 0. And the same follows for numbers if your highest number has 3 digits or even higher. The second step is to read off consecutive groupings of digits in the appropriate length from left to right across the line in the random digits table. Ignore any groups of digits that weren't used as a label or if it is a duplicate number of a label that you've already selected to be in the sample. You may stop when you have chosen n different labels with small n being the sample size that you want. Let's say that we have a labeled population of 30 individuals and we want to randomly sample data from 5 of these individuals. Table D in the back of your textbook has a couple of random digits table values, and line 101 reads off for these values. Read from left to right the numbers 19, 22, skip 39, skip 50, skip 34, 05, skip 75, skip 62, skip 87, and 13, skip 96, 40, 91, and 25 is our 5th. How do we simulate random behavior? We've already reviewed 2 methods as they're the same methods for which to pick random samples or to assign treatments with. Except this time you may stratify the outcome to be in line with the probability distributions of the simulation that you wish to follow through with. A probability distribution is a table that links each outcome of a statistical experiment with its probability of occurrences. Consider a coin flip experiment where you flip a coin 2 times and record the number of heads that had appeared. This table, which associates each outcome with its probability, is an example of a probability distribution. If we had wanted to simulate this many times with a calculator, you may use the random integer function and assign an outcome of 1 to be heads. Run it with n as size 2 for the 2 coin flips for each simulated trial. You would do this many times and the recorded data may serve as your simulation.
So, 2 events, A and B, can either be independent or dependent. If these events are independent, event A happening does not affect the chances of event B happening, and vice versa. Event B happening does not affect the chances of event A happening. To write this in better notation, the probability of event A occurring, given that event B has already occurred, is equal to the probability of event A occurring. And again, this works the other way around. Let's say that T is the sum of A and B, where A and B are independent random variables. To find the mean of T, find the sum of the means of A and B. If we want to find the standard deviation of T, however, we cannot just add the standard deviations of A and B. We must find the variances of A and B, which is their standard deviation squared. Then we can add the variance of A and the variance of B to get the variance of T, which we can then square root to get the standard deviation of T. Now let's say that D is A minus B. To find the mean of D, subtract the mean of B from the mean of A. In order to get the standard deviation of D, again, we cannot just subtract the standard deviation of B from that of A. Instead, we subtract the variance of B from the variance of A to get the variance of D. Then, take the square root to get the standard deviation of D.